Okay, we are moving on with our work on factoring, and today we will up the challenge a little bit and start factoring quadratic trinomials where the coefficient with the x squared is not equal to 1. And that really changes the game. It makes it a lot harder, and I have a few examples here to really help you get through these sorts of problems. So factoring ax squared plus bx plus c, and we'll start with an introduction and then do a few different examples. So there are two common methods here. The one that I did probably forever when I was in high school and for the first probably 15 years of teaching is I just did trial and error. So I guessed and checked, and sometimes it got frustrating. And then I realized I should probably do a little more maybe straightforward or algorithmic method. And so I started using what I call the AC method. Some people call it factoring by grouping. But here are the steps, and we will do both methods. We'll do one with trial and error, and then I'll spend most of the time in this video using the AC method. But here are the steps to it. We want to find factors of AC that have a sum of b. So a, just to be clear, a is the number in front of the x squared, b is the number being multiplied by x, and c is the lone constant. Okay, so we're going to multiply a and c together, okay, and find factors of that product that have a sum of b. So AC means a times c. Then we're going to split the middle term of the trinomial into two pieces. So we're going to split the question that we've been given with the middle term into two pieces. So it's going to turn into a 4-term polynomial. And we're going to split it using those two factors that we found in the first step. Okay, we're going to split the middle term. And then you'll have two separate greatest common factor problems, where you will do those two separately. You'll factor out the GCF, and you should see a common remaining term, and you can combine things together into one binomial. So I'm sure that probably doesn't make any sense right now, but we will do some examples with this method, and I hope it'll make more sense at the end. But first, we are going to do a trial and error method, okay? And I haven't looked at this problem in a while, so I'm going to do it live right now with you. And so it might take me, you might see a little bit of maybe the frustration or maybe a little bit of the time-consuming nature of just doing it with trial and error. So the first thing we want to do is set up our parentheses. I can see that every term, every sign in there is a plus sign, so I'm going to have two plus signs in my parentheses. And then I want to factor the 3x squared into two different terms. And luckily, 3 is a prime number, okay, so it only factors into a 3 and a 1. So we're going to have a 3x and an x to start things off. Okay, and now we need to think about factors of 20 to throw in here. So factors of 20 are 1 and 20, or 20 and 1, 2 and 10, or 10 and 2. 4 and 5, or 5 and 4. So we have those 6 possibilities, and I wrote out, for example, the 1 and 20 different from the 20 and 1, because if we put a 1 and 20 here, that's not going to FOIL out to get what we want, but we still might want to consider putting a 20 and then a 1 in here, okay? So once we have this 3 to start things off, once we have some coefficients in front of the x that aren't 1, we need to think about the order in which we're putting the numbers in. Okay, so let me clean things up a little bit. And I think we can see that neither the 1 and the 20 or the 20 and the 1 work. We're really just testing to get the 19 now. 3 times 1 is 3 plus 20. That gives us a 23. So that doesn't work. That doesn't get us a 19. So these guys don't work. 2 and a 10, or a 10 and a 2. If I put a 2 here, 10 times 3 gives us 30. That's not going to get us close to 19. 10 and a 2. 2 times 3 is 6, plus 10x is 16. That doesn't get us there either. So these guys are not working. 4 and 5. 5 times, hey, it looks like we might have gotten it. So 5 times 3 is 15, plus another 4x is 19. So that gives us the 19 that we're looking for. Okay, so let's clean things up and circle our final answer. And Let's FOIL it to check it out. So 3x times x is 3x squared, outers are 15x, inners are 4x, and the lasts are 20. Yes, and that does check out. Okay, so it looks like we did it correctly. So that's the trial and error method, and you can see that there's maybe a little bit of tediousness with it, maybe. A little, obviously trial and error, right? You're going to see how long it takes. Let's do our next method here. This is called the AC method, okay? And I've copied the steps over on the right-hand side. And so we're actually going to do it with this same problem we just did, 3x squared plus 19x plus 20. So we know the answer to it, but we're going to do it again. Find the factors of AC. So AC is 3 times 20, which is 60. Find the factors of 60 that have a sum of B, have a sum of 19. Okay, so think about factors of 60, 2 and 30, 3 and 20, 4 and 15, do it, okay? So just kind of get familiar with factor tables and times tables in your head. So it looks like 4 and 15. So we're going to be using the numbers 4 and 15 here. Okay, so we did that first step. Split the middle term of the trinomial into 2 pieces using those 2 factors. So we have a 3x squared plus 4x plus 15x plus 20. Okay, and it doesn't matter if we put the 4x or the 15x first. Okay, so this combines together to give us the 19x. We haven't changed the problem, we just split the problem up. And now we will be doing sort of 2 separate GCF problems. Okay, so we've split the middle term, and now we're working on this term. Factor out the GCF of the left 2 terms and the right 2 terms. So it looks like the left term has a GCF of x that we can pull out, and a 3x plus 4 stays behind. And that is our sort of our yellow piece. And then I'm going to get orange in here. So the right 2 terms has a GCF of 5, it looks like, and 3x plus 4 stays behind. So here's what we want. We want the piece that stays behind, those 2 pieces, to be identical, and they are. Okay, so we did that okay. And then we're just going to bring these 2 pieces down here, and they're basically kind of overlapping, 3x plus 4, and then we bring the x plus 5 down here. So that would be our final answer right there, x plus 5 times 3x plus 4. So it's the same solution we got in our earlier guess and check method. I guess maybe what I encourage you to do is try the guess and check method, try the trial and error method first, and if you can't get the solution within 30 seconds or a minute, then go to your AC method, and then that's a little more step-by-step, and it'll take you there. Let's practice the AC method again, and this is a harder one because there are some negatives involved. Okay, so we need to find A times C, which in this case is negative 24. We need to split the middle term of the trinomial. Well, we need to find factors of AC that have a sum of B, so we're not yet done with the first step. So factors of negative 24 that add to negative 5. 12 doesn't do it, negative 8 does it. So negative 8 and 3 will do it. Okay. And then let's split things up. So we have a 4x squared minus 8x plus 3x minus 6. Okay, so now we've done the first 2 steps of what we needed to. And then, just like I said before, we are going to do 2 separate GCF problems. So this first one, there's a GCF of 4x, and that turns into x minus 2. Let me check that, 4x squared minus 8x, yeah. And the second one has a GCF of 3, and also leaves behind an x minus 2. And so once again, you want to make sure that these guys are the same. Okay, if they're not the same, then you made a mistake somewhere along the way, and go back and see if you can fix it. And then you're sort of rearranging, you're overlapping the x minus 2 and bringing together the GCFs. And that's our final answer right there. And lastly, on this video, I just want to do one that models finding a GCF first, okay? So whenever you have a problem, particularly with a number out front that has a lot of factors, it's going to get hard unless you pull out a greatest common factor first. So just to be super clear there, is this going to be a 4x times 5x? Is this going to be a 2x times 10x? You know, there are quite a few possibilities there. And then if you use a trial and error method without pulling out a GCF, it's going to get tough. Okay, so let's bring these over here. And let's pull out a GCF first. So it looks like there's a GCF of 5. Okay, so we can pull a 5 out front, and that stuff stays behind. Okay, and now it's a much more accessible problem to factor. And maybe you're remembering what we just did. I think right up here we just factored that guy. Okay, it's the same problem. Okay, so we can actually, I'm going to copy and paste this. And so this is going to be 5 times, let's get that right there. There's our solution, right? Okay, so we already factored that problem. So feel free to be a little bit efficient like that. And there's our final answer to that particular problem. Key there was to pull out a GCF, makes your life so much easier. All right, that's a good place to stop.